Hello everyone, welcome back. Today we will be solving one LeetCode question, longest increase subsequent. Given an integer array nums, return the length of the longest strictly increased subsequence. Let's take a look at the example. Here we have the array with the element 10, 9, 2, 5, 3, 7, 101 and 18. What is the longest subsequent from this array? The answers can be either 2, 3, 7, 101 or 2, 3, 7, and 18. Most of the answers are correct because they are strictly increasing subsequent. Let's take a look at this example to see how can we come up with the solution. We know that the prompt is asking about the longest increasing subsequent. Whenever you see the word longest, the largest, the minimum, it kind of suggests that we can use dynamic programming to solve the problem. And instead of solving the whole or the entire problem, we can just break the problem down into a smaller problem. Let's say we only have the element 10 in this array. What is the longest increasing subsequent in this array? The answer is 1, because here we only have one element. And what about when we have 10 and 9? The longest increasing subsequent is still 1 because here we don't have any increasing order. And what about 10, 9, 2? It's still 1 because these are decreasing. And what about 10, 9, 2, and 5? The answer is 2. Why? Because here we can take 2 and 5. These two are the increasing subsequent in this array. Now let's try to initialize a DP array that can represent the longest increasing subsequent for each of the element here. Here we have the DP array with the length with the same length, and each of the index will be represent the longest subsequent for the index in the nums array here. So for this index, for the index 0 here, it represents the longest subsequent, the longest increasing subsequent for the element 10. And here is the longest increasing subsequent for element 9. I will also note here that we initialize DP array with the length of the num array and fill with 1. In order to explore the entire array here, we know that we have to use loop to explore the element here. I will create a variable called I, and it will start with the index 1. We start with the index 1 because we know that if we are at the first element or at the index 0, we know that the longest increasing subsequent is always 1. So we can just start with the second element here. During the loop, when we are at each of the element, we will try to traverse back to see which element that is smaller than the current element. If it is smaller than the current element, we can grab the longest subsequent increasing value, add 1 to the current element. Let me show you what I mean. Let's say here, our I here is at the index 1. I will also create another variable called j that starts from the first element. Now, j is here. We will check from j until I to see if there are any element that is smaller than I. If it is smaller than I, we will grab the value from this DP, add 1 to the I DP here. Let me write it down here. Loop from j until I, not including the I. If num j is smaller than num I, grab the DP j. Remember, DP here will store all the longest increasing subsequent for each of the element. The j element, which is 10 here, we add 1, and then we store the result in the DPI. But before storing the result here in the DPI, we have to check max.max between this value and the current DPI. Let's say j is here and I is here. We will loop through each of the element here, and then we will try to get the max of the entire subsequent. That's why we have to check before restoring the value. Here I will put DPI equal the max between DPJ plus 1 and the DPI here. I will also create another variable called max that will store the final maximum longest increasing subsequent as the answer. Here I will initialize the max variable here with the value 1 because if we have only one element, the longest subsequent is 1. And from each of the comparison here, we also want to update our max here. So max equal the max function between the current max and dpi. And after that, at the end of the loop, we can just return back the max result. Let's go through our example here. So here I equal 1, I is here, and j equals 0, j is here. The first loop is I, go from the index 1 until the end of the array, and the inner loop is j, start from the 0 index until the I index. So when I is here, we check j here. If j is smaller than I, the answer is no, so we skip it. So I move to here, and we check again. If 10 is smaller than 2, no, and then we move j to here, and we check again. If 9 is smaller than 2, the answer is no, so we end the inner loop, and then we move the outer loop. So I will be here, and j will start from 0 again. So from here we check if 10 is smaller than 5, no. We move j to the next element. If 9 is smaller than 5, no. We move j again to another element. If 2 is smaller than 5, yes. We will use our formula here. So the dpi here will be equal to the dpj plus 1. The dpj plus 1 is 1 here. 1 plus 1 is 2. Which one is bigger? So the answer is 2. So we will put 2 here. And then our max equal max and the dpi. Max here is 1. The dpi here is 2. So the answer is 2. And we reach the end of the inner loop, and then we move the outer loop to the next element. And we start the inner loop from the first element again. So we check 10 and 3. 10 is not smaller than 3. So we move j to the next element. 9 and 3. 9 is not smaller than 3. So we move j to the next element. 2 and 3. Is 2 is smaller than 3? Yes. Now we use our formula. So now the dpi will be equal to the dpj plus 1. dpj is 1. 1 plus 1, and dpi is 1, so this one 1 plus 1 is 2. 2 and 1, which one is bigger? This answer is 2, so we update our dpi here equal to 2. What about the max? The current max now is 2, and the dpi here is 2. 2 and 2, the answer is still 2. Let's move j to the next element. 5. Is 5 smaller than 3? No. We reach the end of the inner loop, and we move I to the next element. 7. J here will start from the first element again. 10 and 7. 10 is not smaller than 7, so we move j to the next element. 9 and 7. 9 is not smaller than 7, so we move j to the next element 2. Is 2 is smaller than 7? Yes. dpj is 1. 1 plus 1 is 2. We check between 2 and dpi. dpi here is 1. 2 and 1, the answer is 2. And what about max? The current max here is 2. 2 and 2, the answer is still 2. We also have to update our dpi here is 2. Now, let's move j to the next element, 5. The dpj here is 2. 2 plus 1 is 3. dpi now is 2. 3 and 2, the answer is 3. So we update our dpi here to be 3. And then for the max, the current max now is 2, and the dpi now is 3. 2 and 3, the answer is 3. Next, we move j to the next element, 3. 3 and 7. 3 is smaller than 7, so here dpj is 2. 2 plus 1 is 3. And the current dpi here is 3. So 3 and 3 still 3. And what about max? The current max here is 3. And the dpi here is 3. 3 and 3, the answer is still 3. We reach the end of the inner loop, and we move I to the next element. And j, we also start from the first element again. Is 10 is smaller than 101? Yes. So here, dpj is 1. 1 plus 1 is 2. 2 and 1, the max here is 2. So here we update our DPI here is 2. And what about the max here? The current max here is 3 and DPI is 2, 3 and 2. The answer is still 3. We move J to the next element, 9. 9 is smaller than 101. So here DPJ is 1. 1 plus 1 is 2. And DPI here is 2. The max between 2 and 2 is 2. So here is still 2. And we check between the current max here is 3. And the DPI here is 2, 3 and 2. The answer is still 3. We move J to the next element. 2 is smaller than 101. So here DPJ is 1. 1 plus 1 is 2. DPJ is 2. So here still 2. And what about max? The current max is 3. And the DPI here is 2. So the answer is still 3. Let's move J to the next element, 5. 5 is smaller than 101. DPJ is 2. 2 plus 1 is 3. DPI here is 2. 3 and 2. 3 is bigger than 2. So we update our DPI here to be 3. And then we check the max here. The current max here is 3. 3 and 3. The answer is still 3. We move J to the next element. 3 and 101. 3 is smaller than 101. So here DPJ is 2. 2 plus 1 is 3. And the DPI here is 3. So the answer is still 3 for the DPI here. And what about max? The current max here is 3 and DPI is 3. The answer is still 3. Let's move J to the next element. 7 is smaller than 101. So DPJ is 3. 3 plus 1 is 4. DPI is 3. 4 and 3. 4 is bigger than 3. So we update our DPI here to be 4. And what about max? The current max here is 3. The DPI now is 4. 3 and 4. 4 is bigger than 3. So we update our max here to be 4. We reach the end of the inner loop. So we move I to the next element. And we start J from the first element again. 10 is smaller than 18. So here DPJ is 1. 1 plus 1 is 2. 18 here. DPI here is 1. So here 2 and 1. The answer is 2. And what about max? The current max now is 4. And the DPI here is 2. The answer is still 4. We move J to the next element, 9. 9 is smaller than 18. So here DPJ is 1. 1 plus 1 is 2. And DPI here is 2. So the max here is still 2. And what about the max here? The max here, the current max now is 4. And the DPI is 2, 4 and 2. The answer is still 4. Let's move to the next element, 2. 2 is smaller than 18. DPJ is 1. 1 plus 1 is 2. DPI is 2. The max here is still 2. What about the final max? The current max now is 4. 4 and 2. The answer is still 4. Let's move J to the next element. 5 and 18. 5 is smaller than 18. So DPJ is 2. 2 plus 1 is 3. DPI is 2. So we update our DPI here to be 3. And what about max? The current max is 4. 4 and 3. The answer is still 4. Let's move J to the next element, 3. 3 is smaller than 18. So DPJ is 2. 2 plus 1 is 3. DPI now is 3. 3 and 3. This one is still 3. And what about the max? The current max is 4. 4 and 3. The answer is still 4. We move J to the next element, 7. 7 is smaller than 18. So here DPJ is 3. 3 plus 1 is 4. DPI is 3. So we update our DPI here to be 4. And what about max? The current max is 4. And DPI is 4. 4 and 4. The answer is still 4. Let's move J to the next element, 101. 101 is not smaller than 18. So we reach the end of the loop here. And the final answer is 4. Let's code out the solution. First, I will initialize a DP array with the length of the num array, and we fill each of the element with the value of 1. Here, I will initialize the variable called longest, instead of max because I don't want you to confuse with the max function. Next, we will have our loop here, I that start from the index 1. We have to loop through the entire array. So here is going to be another loop that we start from the first element, the index 0, and then we loop until I. In the inner loop here, we will check if num j is smaller than the num I. If it is smaller, we want to update our dp array. So dpi equal max.max between the dp I and the dp j plus 1. And after that, we will also have to update our longest variable. So longest equal max.max between the longest, the current longest, and the dpi. And at the end of the loop, we return back the longest. Let's check the result. What is the time complexity for our implementation? The time complexity is going to be O of n squared. Why? Because here we have two nested loops. The outer loop starts from the index 1 until the end of the array. In other words, it loops through the entire array. And we also have the inner loop that starts from the first element of the array until the I index here. So here is n squared. And what about space? Space is gonna be O of n. Hope you guys enjoyed it. See you next time.